All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you should have x minus 3 times x minus 3, or you can write that as x minus 3 squared. So either one of these would be fine. For the math knowledge question, which one of these would make lines RS and UT parallel? If B and F were congruent, that would not make parallel lines. We need to look at this line and the transversal. C and F would make this line and this line parallel, so not that one. If A and C equal 180, that doesn't help us any. And A and F equals 180, that would make no help. The one we want to pick is B and E, because those are alternate interior angles. So if those are congruent, then our lines would be parallel. So we're looking at lesson 26 today. We're going to look at central angles and arc measure. So hopefully after this lesson, you'll understand a little bit more about central angles and arc measures. So an arc is part of a circle that consists of 2 points that are on the circle called endpoints, and all of the points on the circle that's between them. When two arcs on a circle share exactly one endpoint, they're called adjacent arcs. So if we have a circle, this is what an arc would look like. This part here. And then if we have another arc here that share the same endpoint right here, these two arcs are adjacent because they're right next to each other. For central angles, if you have a vertex at the center of a circle, this angle that I just drew is called a central angle because the vertex is at the center of the circle. So there's a better picture of a central angle. We're going to look at minor, major, and semicircle arcs. So a minor arc is one that is smaller than half of a circle. Minor arc is always going to be in between 0 and 180 because it has to be less than half of a circle. A whole circle is 360, so half of 360 is 180, so this one has to be less than 180. The minor arc measure is the same as the measure of the central angle. So if this is from here to here is the arc, and it is 85 degrees, this central angle here is also going to be 85 degrees. All minor arcs are named using the two endpoints on your arc. So if this is A and this is B, you would name the arc as AB. Minor arcs only use two letters to name them, 2 points. So you pick your two endpoints to name a minor arc. For a major arc, it's an arc that is larger than half of a circle. So it's going to be in between 180 and 360. And you can find the measure of the major arc by taking 360 and then subtracting the associated minor arc, because they have to add up to 360 together. So if I drew this out, and we had this angle here was 85, this is the major angle that goes with this major arc. And so if this is 85, 360 minus 85 is 275. So this major arc would be equal to 275. And then all major arcs are named using the two endpoints of the arc and a point on your circle that's in between the endpoints. So if we have a circle and we have A and B, and if I said A and B, that's just going to assume it's the minor arc. So to make it so that it goes around the circle like this, we need to pick a point over here. And so this major arc would be ACB. And that's how you know that it's a major arc, because it tells you you have 3 points and you have to go through all 3 of those. So you go from A to C to B. So major arcs are named using 3 points, always. Looking at a semicircle, it's an arc that is equal to half of the circle, exactly half. So the measure of a semicircle is 180 degrees. So semicircles have to equal 180 degrees. That's half of 360. If it doesn't equal 180, then it's not a semicircle. Like your major arcs, semicircles are also named using 2 endpoints and a point in between the 2 endpoints. So if it's not a minor arc, then you're going to use 3 points to name it. But if it is a minor arc, you only use 2. So let's look here. We want to identify a central angle, a minor arc, a major arc, and a semicircle. So a central angle could be angle TCH. That would work. Or angle HCD. Either one of those would be fine. For a minor arc, there are 2 that they give you. Arc TH or arc HD. Both of those are less than half of a circle. Now for a major arc, you could do arc HTD. HTD is more than half a circle. You could also do arc TDH, which would be this whole thing. You could make this DTH or HDT, but those are really the only 2 that you can do for major arcs. And then the only semicircle that you can name is going to be either THD or DHT. So that's the semicircle that you would have for this circle. Okay? Looking at this one. What is the measure of arc AP? Well, this arc has the same measure as this central angle. And what is the central angle measurement here? There's a little box there. That means 90 degrees. So the arc also has a measure of 90 degrees. So that would be your answer there. So looking at congruent arcs, if you have 2 arcs that are in the same circle, or if they are in congruent circles and they have the same measure, they're called congruent arcs. So let's look at this example. They tell us that the measure of arc CK is equal to the measure of arc TL. We want to find the value of x and the measure of each arc. Well, if they're equal to each other, we can just set 7x minus 2 equal to 5x plus 6. And then if we solve, we should get 2x minus 2 equals 6. So 2x would equal 8. And so x would equal 4. So that's your value of x. And then you need to plug in to find your arc. So 7 times 4 minus 2 would be 28 minus 2, which is 26. So each arc has to be 26 degrees. If you want to check, you can plug it in over here. 20 plus 6 is 26. But since they're congruent, you shouldn't have to plug it into both. Okay, so now we're going to look at postulate number 14. It's the arc addition postulate. It's very similar to the segment addition postulate or the angle addition postulate. The measure of an arc formed by 2 adjacent arcs is just the sum of the measure of the 2 arcs. So if we have on our circle this arc here that's 40 degrees and then this arc here that's 50 degrees, if you add these together, that gives you 90 for the whole arc. So that's pretty straightforward, hopefully. So let's look here. We want to use the arc addition postulate to write an expression that represents arc DB. So So the measure of arc DB should be equal to this arc, which is the measure of arc DC, plus the measure of this arc here, which is arc CB. So that's part A. And then to find the measure of arc DB, we're just going to plug in. This arc measures 35, and this other arc measures 95. So if you add those two together, you should get 130. And so that would be your arc measure. Looking at one more example, we have floodlights that are going to be mounted on a building to illuminate the exterior of a right angle. And one floodlight illuminates an angle of 50 degrees. How many floodlights are needed and how much overlap will there be? So we have a building here, and it tells us we have a right angle, and we want to illuminate this part out here. So if this is 90 degrees, this part out here is going to be 270 degrees because they have to add up to 360. And it says one floodlight will do 50 degrees. So how many floodlights do we need to cover 270 degrees? Well, 270 divided by 50 degrees is going to be 5 point something. 5.4. So we can't use just 5. That won't give us enough. So we'll have to use 6 lights. And if we have 6 lights at 50 degrees each, that would be a total of 300 degrees. And so we would have an extra 30-degree overlap. So that's what you would do for that one. All right, so y'all try these 2 practice problems. And then once y'all are finished, unpause the video and I'll go over them. So we're going to draw a diagram of a circle. So there's your circle. And I'm going to name it circle A. We want to identify a central angle. And so this is going to be B, and this is going to be C. So this is my central angle. My minor arc is going to be here. And then my major arc is going to be here. And so I'll put a point D so that I have 3. So that could be your diagram. Now we're going to look at part B. We want to identify the measure of the minor arc. Well, the minor arc is the one that is less than 180 degrees. So which one of these is the minor arc? 115, which is the measure of arc RS. So that would be your answer there. Looking at this practice problem, y'all see if you can do it by yourself, and then unpause the video and I'll go over it. It tells us that arc JK is congruent to arc LM, and so we can say 2x minus 15 equals x plus 30. And so if you subtract x, you get x minus 15 equals 30, and then add 15, x is 45. And then if you plug in 45 plus 30 is 75 degrees. So that would be the measure of each arc. And you should still get 75 if you plugged it in there. Okay, looking at this practice problem, we want to use the arc addition postulate to write an expression that represents arc AB. So AB, this is going to be the minor arc. So we're going to have to make it less than 180. So we know we're going to do that arc. So the measure of arc AB will equal the measure of this one, and this one. So the measure of arc AD plus the measure of arc DC plus the measure of arc CB. And so that would be your answer. All right, looking at this one, we want to find the measure of arc DEG. So DEG. We know that the total circle has to equal 360. So if we do 360 minus 180 minus 140, this one has to be equal to 40. And then to find the measure of the arc, we're just going to say 180 plus 40 is going to equal 220. Okay, so that's how it would work for that one. For this bottom one, we have lamps that have 100 degree arc, and we want to make a complete circle. So if we used 3, that would be 300 degrees, but a circle is 360. So we would need to use 4 lamps. And if we used 4, that would be 400 degrees. And so we would end up with a 40 degree overlap from the lamps. Okay, so now let's look at the challenge question. So y'all try this one by yourself, and then once you unpause the video, I'll go over it. So we want to find the measure of angle BE. So the first thing we need to do is find the percentage that goes with it. So that would be 7% plus 17% plus 15%. So that is 39%. But it asks for the arc measure. The total of a circle is 360. So if we take 360 degrees and multiply it by 39%, or 0.39, that comes up with 140.4 degrees. And so that would be your answer for part A. What type of arc does arc AED represent? So if we add those up, 35 plus 15% is 50%. And then if you multiply it by 360, that's going to give you 180 degrees. So it represents a semicircle. And the reason is because it measures 180 degrees. So that would be your answer for that one. So your homework tonight is 1 through 30. So make sure y'all do those so that we can go over any questions you have tomorrow.